all that, I don't want to do it that way, I want to do it this way. All right, now that we got that said and done. When I talk about factoring, and I say I want you to factor something, can somebody tell me what the word factor means? Okay, now the thing's not working. I didn't touch them right. Oh, okay, thank you. I didn't know I did. It's a conspiracy. And we all know whose fault it is. Whose fault is it? Bush's fault. When I asked you about factoring, what does factoring mean? What does the word factor mean in math? Anybody know? Anybody want to take a stab at it?
And there's some numbers that are multiplied together.
Basically breaking it up. Yes. Factor means break up whatever you're asked to factor. Now, everybody does that every day. If I asked you what break up factors of 54, most of you will say, oh, that's 6 times 9. Although there will be one of you that says, oh, that's 2 times 27. Not many people will say 2 times 27. But most of you will say 6 times 9 because of what? Your what? Multiplication tables, right? Most of you, 90% of you will say 6 times 9. You just factored 54. If I tell you to factor x squared, you will break it up into what? X times x. You just factored x squared. Can you factor 7? Yes, you can. Into the only numbers that it will factor into is 1 and 7. It's called a prime number. We'll talk about that in just a minute. Now you notice I'm using a little tree diagram here. It's the only time you don't see me use it. I do not use the tree diagram when I'm doing factoring or I'm doing the least common multiples or greatest common factor. Why it's confusing to students. But when I'm showing just factoring in two terms, y'all can grab a hold of that a whole lot better than anything else. There's some things you can't factor. 7 you can because it's a prime number. What if I was to put up x minus 1? Well, see, you can't factor x minus 1 because it is worse than a prime number. It's not factorable. You can't factor it because you don't know what x is. And you don't know what 1 is being taken away from. So you can't factor something like this. But you can factor something like that because something is in common. What's in common with x squared and x? X, and you can factor out what's called a common term and say x times x plus 1. Now we really don't care about this because we're not going to get into that right now, but what I'm trying to tell you is that you can factor pretty much everything. You could factor this guy, which we don't need to worry about, but x squared plus 4x plus 4. And you can factor that into x plus 2 times x plus 2. In other words, if you multiply these two together using the FOIL, pronounce it however you like, then using the FOIL method, if you multiplied that, you would get this. Thus, 6 times 9, 9 times 6 is equal to 54. X plus 2 times x plus 2 will give you x squared plus 4x plus 4. Don't care about that either. But what I'm really trying to get you to understand is the word factor means what? Break up. It's just like brakes on your car. You had the old-timey brakes on your car, the drum brakes. You can't diagnose, because brakes are, those old-timey brakes, the drum brakes, are real bad about making noise. Yes, making noise whenever I do this, whenever I do this, whenever I do this. You cannot figure out what's wrong with the brakes until you take the drum off and you look around and you start taking things apart. And that's the way that you understand, that's the way that you find out what's wrong with the brake, and where it's leaking, or where it's making a noise, or whatever the case may be. Same thing with this. You can't break down a problem, you can't solve a problem until you break it down to its parts. Now, if you take something like 54, there's two ways to factor 54. There is to factor it, just like we did while ago with 6 times 9, and then there is prime factorization. That is factoring. Prime factorization is when you do 6 times 9, and then you break down the 6 to 2 times 3, and break down the 9 to 3 times 3. This is called factoring, and this is called prime factoring. Now, prime factoring is what I'm interested in, because that will give way to our least common multiple, greatest common factor, or in section 2, the greatest common denominator, or least common denominator. Now, in order to understand prime factorization, you have to know what a prime number is and what a composite number is. Most of you know that, and I'm just going to go over it real quickly because I don't want to insult your intelligence. But prime factorization is based on prime numbers, and composite and factoring is based on composites. Don't really care about composite factoring because everybody can do that. I'm interested in this. So we're going to part and drill until each of you know how to do prime factorization. So let's talk about prime factors. What are prime numbers? Well, prime numbers, a real easy definition. Prime numbers are numbers divisible by themselves and what? And 1. Composites are all other numbers besides the primes. So if you list the prime numbers, 1, 2, 3, 5, 7, 11, 13, 17, 19, dot, 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 dot. In other words, not all the, you can't say all the even numbers, because you can't say all the odd numbers because 2 is not odd. You can't say even numbers because the rest of them are pretty much not even. So you can't just say one type of number. The composites are all those that are left. 4, 6, 8. Just do your multiplication tables. 9, 12, and so on. 10, 12, sorry. And what do these numbers have in common? Well, these numbers are simple. These numbers are your multiplication table numbers. The numbers that you get when you do your multiplication tables. Think about it. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. That's the numbers you get there. These numbers, you don't get them anywhere except for the first of your multiplication table. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. I meant 1 times 3 is 3. 1 times 4. 1 times 5 is 5. 1 times 7. That's those numbers. And these are the numbers that you want to break everything down into. In other words, in these first 2 sections, this is your universe right here. And these numbers right here are going to make up your universe right there. 2, 3, 5, 7, 11, sometimes 13. A-E-I-O-U, and sometimes Y. Remember that. 2, 3, 5, 7, 11, and sometimes 13. There's no other numbers in your universe for these next two sections. First thing I'm going to do is I'm going to throw up 50 on there. I'm going to say break it up into prime factorization. Somebody's going to go, oh, that's 5 times 10. Didn't listen to a word I said. Okay? Prime factorization. These are the only numbers in your universe. 10 is not in your universe. You can't say 5 times 10. If I tell you 50, you got to break it up in terms of this. Okay? Yeah, 5 is in there, 5 times 10, but you can't use 10 because 10 is not in there. You got to use something else. So, let's take 50 for example. And let's break it up into prime factors. No even class. Break it up. Break it up into prime factors. Well, the first thing I do is I put 2, 3, 5, 7, 11, and sometimes 13 at the top. I do that with every single problem that I do up here. I do it when I do it in class. I do it when I do it in the office. If somebody was to come up to me and ask me to do the prime factorization of whatever, first thing I would do is write those numbers up there. I don't care how many degrees you got, I do it because I don't want to forget which numbers we use. And now I draw a little chart like that. And this is where I'm going to run into problems with somebody who's going to go, I don't do it like that, I do it with a tree. Well, fine, you do it with a tree. Just don't cry when what? You get it wrong on this. Because you won't get this part wrong. You'll get the part when I'm trying to find the least common multiple and the greatest common factor. That's where you'll get it wrong, and then you'll say, well, yeah, but I just don't understand. Well, you chose the route that you chose back in 5.1, back in the first day of class. Okay? All right, so the first number I'm going to pick is 2. Do I have to pick 2? No, I'm going to pick 5 if I want to. You pick whichever one you want. I don't care. Multiplication is commutative, so it doesn't matter if 5 times 2 is the same as 2 times 5. It doesn't matter. I'm going to pick 2 because the first number I come up with. 2 will go into 50 how many times? 25. Draw another line. Now what number will go into 25? 5. Now leave, oops, I can't write. That'll leave 5. And then what number will go into 5? 5. When you get a 1 here, you're done. And this right here, we use green. And right here is your prime factorization. So your prime factorization for this number is 2 times 5 times 5, which is equal to 50, or 2 times 5 what? Squared is equal to 50. Now, that's a piece of cake. Not many people have a problem with that. The only ones that have a problem are the ones that are saying, well, I don't want to do it. Like I say, you on your own. Some of you have seen it done like this before. Some of you have never seen it done like this before, but you write it down and you're seeing how to do it. That's the 3 top people you got to do. RAD, then those that, okay, and then those that never seen it before and going, okay, I've never seen it before, so I'm going to write down. Those are 3 types. You want to raise your hand and say, oh, well, I'm used to it. No. You want me to raise your hand or say a word? All right, let's do an error. Let's do 54. 2, 3, 5, 7, 11, and sometimes 13. Can 2 go into 54? Yeah, remember the guy in the building? I have to kind of explain that in 54. Yes, 2 will go in. You can use 2, you can use 3. You can use whatever you want, as long as it will go into it evenly. I'm going to use 2 because 2 will go into 54 27 times. So 2, 27. All right, 2 won't go into 27, but what will go into 27? 3. So you put a 3 on down there. Now what? 3. Now what? And you're done. Why? Because you got a 1. So this is your common denominator. I mean your prime factorization. So that'd be 2 times 3 times 3 times 3, which is same thing as 2 times 3 what? To the third is equal to 51. So this is your prime factorization, or this is your prime factorization. And I always get, well, here, why couldn't you write 2 times 27? Well, 27 is a composite number. Go back to the definition that I showed you at the beginning of the class. Well, I thought I did. Oh well. There it is. 27 is in this group. You want a prime number around 27, what would it be? 29, Hubert. That's right, class. Because 29 doesn't have a what? Doesn't have a multiplication table. Give me a multiplication table. Blank times blank is equal to 29. 1 times 29, that's it. You don't have a 3 times blank is equal to 29. Okay? We feel good about ourselves? Let's try another. Let's try, I gotta discourage you sometime. Let's try 100. Something simple. And after I get your confidence up, then I'll jerk really out from under. 2, 3, 5, 7, 11, and sometimes 13. I'll give you a hint. I'm going to start with 2. How many times will 2 go into 100? Well, it ends in 0. 2. Go in there 10. I'm sorry. I just had a brain bubble. Somebody said 10 and it messed me up. So I 2, 25. And then what? 5. 5. And then 5. 2. 1. I'm thinking of 3 things at one time, excuse me. And a lot of people say, well, I got a 10. Well, yeah, you got a 10 over here, but you still got to break it up. And what's 10 times 10? 100. What's 25 times 4? What's 2 times 50? You're still going to get 100 no matter what arrangement you have. You could have started with a 5. You could have started with a 5. That would have been 5 times 20. And then 2, 10. Then 2, 5, 5, 1. Either way, it doesn't matter what combination you pick. You're going to get the same thing. 2 squared times what? 5 squared is equal to 100. Now, a lot of people say, well, Hubert, I've always had problems with finding out what will go into what. Well, I'm going to cover that base for you. Go to your handy-dandy computer. Go to dang old Google. And all you have to pull up is the divisibility rules. So I got to pull up if you know how to spell it. I don't. Divisibility rules. Dang old visibility rules. Dang old hit images. Dang old pick whichever one you want. Dang old tell you what. Dang old King of the Hill. Dang old you ain't never watched King of the Hill. You need to. Dang old learn something. There you go. Print that out and you feel good about yourself. So you won't have to put smokestacks on your pickup truck. Okay? So if the last digit is even, what can you divide into it? A 2. What if the last digit is a 0 or a 5? It's divisible by 5. What if the last digit is 0? It's divisible by 10, which means it's divisible by 5 and 2. So, and they got a whole bunch of them. You can find them any which way you want. Just dang old click on no.
Oh God, you don't
Right there. Oh, that's the same one. It works. Well, you just have to find them. More images. There we go. Dang old, be quiet. Dang old, I'm talking. They're in the book. What page?
Page 212.
All right, everybody turn to 212. And you see it. I'll turn to 212 also. I thought I pulled up the book a while ago. Did I not? I guess not. 5-1. I did. And 212. There it is. Dang old top of the page. Now, of course, you will have to print that out, and you'll have to let's see, what's the word I'm looking for? Memorize, which means you'll have to work on it a little bit. Then you have to work. So, printing it out, that'll take, at least a couple of days to print it out. And then they'll have to memorize it. That'll take at least, a week?
Maybe 2 as well.
Yeah. So, so they'll give you a few more excuses to, fail the first test. Is that you had to memorize that. So hopefully y'all can take the week or two to print it out. The cat don't pee on the keyboard and your grandmother don't die 5 times. Let's do another one. Let's bump it up a little bit. What do you think? Getting ready to pull that rug out. You hit your head on the back on the floor. All right, let's try. Let's try 144. And then we'll move it up to the thousands. 3 digits up toward the thousands. What goes in the 12? 2. So it ends in 4. 2.
I just got out of doing math, if you don't mind. That was like
I'm not gonna.
7,000 pages long.
You'll start with 2. Why do you start with 2? Because it ends in 4. Now you don't have to. You can find something else to go into it. That's fine. There's a saying in real world KISS method. What's the KISS method? Keep it simple. Whatever that last word is. Keep it simple. If you know 2 will go into 144, why do you go look for something else? It's called keeping it simple. Alright? You're not trying to impress anybody. You're doing your homework at home. You're not trying to impress anybody. Don't try to pick a bigger number. Just go with 2. 70 what? Alright, now you got it down to your multiplication pages. what numbers go into 72? 8 times 9, Hebrew. Good. But you don't have an 8 times a 9. But you have what? 3. If 3 goes into 9, 3 will go into this number. That's your thinking. So 3 will go into 7 how many times? And then that'll leave a 1. Because 2 times 3 is 6. You subtract, that'll leave a 1. You're doing this in your head. You're doing this in your head. That means you're making your brain what? Work. And you're not using a what? Calculator. Okay? So that leaves a 1, and that 2 makes 12. How many times does 3 go into 12? Look up there. It's a miracle. 3 will go into 24 how many times? 8 times. Now we're down to 8. What up there will go into 8?
2.
Look up there. There it is. How many 2s we got? 1, 2, 3, 4.
I basically get the same thing.
There's no way you're not going to get the same thing unless you do it wrong. Because the numbers that you see here will come out no matter what numbers you start with. Now, if you have a number that's not in this list right here, then you've done something what? Wrong. This is what you should have. Either a mix-up of these numbers, or 3 to the second times 2 to the fourth, or 2 to the fourth times 3 to the second. Those are the only options. Now let's go to your handy-dandy homework, and let's pull up some problems so we can discourage you before you go home and do it.
You only have one piece of gum in.
I don't know why.
I can never get gum that's like elastic enough to blow up.
That's because they don't make gum like they used to. I don't know. No, I have 15 pieces in my mouth. Okay. All right, there's a simple one. We already did one like that. Let's move on to the ones that will discourage you. Ooh, there's one. There's a test question. I have one right here. What happened to it? It disappeared. Oop, no. I'll have to turn. Okay, we'll go with this one. Okay, it must be changing them as I go. Okay. All right, we'll try that one. 212. Prime factorization of 212. You automatically know what's the first number that'll go into it.
2.
There you go. You already learned. And a lot of people say, when I teach y'all this, why in the world do we have to learn how to do this? We'll never use this in real life. Oh, yes, you will. It's called adding and subtracting what? Fractions. And some of y'all cannot even read the dadgum tape measure. And I mean y'all, I mean at Tri-County Tech, I don't mean y'all in here, I mean students. Some students don't know how to read the tape measure. You know why they don't know how to read the tape measure? Because they don't know how to add and subtract fractions, much less divide or multiply. Do you know why a lot of people don't know how to add and subtract fractions? Because they've never been taught how to find these things. Alright, y'all said 2. And you know another good thing about this, doing it by hand, what are you doing each time you're dividing? You're using your head. Let me ask y'all a question. Let's say you were at home one night and you watching the movies You watch Rocky, okay? And you watch Rocky and you say, heck, I'm going to go work out tomorrow. And you go out and you go to the gym and you put 215 pounds on the bar and you do 3 sets of 10 of squats. And you put 25 on each, you put 25 pounds on each set. You do 10 more. Then you do 10 more. You do 4 sets. Okay, 4 sets. What's going to happen the next day? You're not going to be able to walk. Why?
Actually, it's in 2 days, you're not gonna walk.
You work with me here. All right, go into 4 sets of squats. You haven't worked out in forever.
You're gonna die.
Why? Why can't you walk the next day?
Because those muscles haven't been used for
Exactly.
When they die down,
Now, what is that? What does your leg muscles have to do with your brain?
doesn't have use our brain.
We don't use our brain anymore. We don't. Because we've got a little idiot box called a calculator, and our teachers have told us to use that calculator to go to the bathroom, to use that calculator to drink water with, to use that calculator to, and y'all say, I'm being facetious. We have been told to use that calculator for every mathematical operation that we do, whether it's in life or in school or in academia. And therefore, have you ever went to a store and gave somebody 56 cents and the bill was $20.56 and watch your head explode?
Yeah.
Right.
That's why, because they were weaned on one of those calculators. But you know what I'm talking about. Calculator. Can't think. It says $20.56 and the bill is $19.56 out of the dollar. Real simple math. But people can't do it because they have to punch it in on a calculator because their confidence and their brain muscles have been working so long that they have to rely on the calculator to tell them a dollar. I had this happen. McDonald's up on 81, right there at 81.85. I shut down not only the register, the guy at the register. I shut down the manager. The manager had to go back in his office and get a calculator because he couldn't do the subtraction. It was like $10. I gave him $10.27, and the bill was $5.27 or something like that. It was something real simple. And he could not. He said, "Hold on a minute, because the register won't do it. Let me go get my calculator." So that's the people. So if you're one of those people, don't say anything. Don't raise your hand. You need to work on it. And the way that you work on it is right here. 2 will go into 2 one time. Okay, 2 minus 2, that's 0. So this comes down. 2 will not go into 1, will it? So 0. But 2 will go into 12 how many times? And now you got another even number. So 2 will go into 10 5 times. 2 will go into 6. Uh-oh. I've got to be careful here because I don't know about 53. I've never seen 53 in multiplication tables. Have you? So that means it may be what? It may be prime. Well, let's think a minute. Go back to your divisibility rules. I don't know. 2? No, 2 won't work because 2 won't go into anything other than 13. The only number that I can think of that will give me a 63 or a 3 is a 63, but that's too much. Is there any other multiple? Think of your multiplication tables. 63 is the only number that I can come up with that ends in 3. You can think of another number that ends in 3 with your multiplication tables. 3 times 7 is 21, 3 times 4 is 24, 3 times 8 is 24, 3 times 9 is 27. Think of a number that you get. Only one I come up with is 63. What do y'all come up with? I can't think of a number that will give me a 3 except for 63. So what is that? Prime. So our final answer is 2 times 2 times 53. And then you punch it in so you can feel good about yourself. And not have to wear sunglasses indoors. 2 times 2 feel good about ourselves. Finally.
I thought I was hitting like a retard block.
No!
53.
Come on, there we go. 627. That ought to pull the rug out from under you. That ought to make you feel bad. Can't do it. 627. What's the only number that you can come up with that ends in 7 with your multiplication tables? 3 times what? 3 times 9 is what? 27. So that tells you what? What will go into this one? 3. All right. Brown, Dawson.
Here.
Oops, sorry, Carrie. Okay. Dedu. I didn't say that right. How you say it? Dido. Dido. Don't know where that came from. Edwards. Okay, quiet one. Elliott. And Grubbs is here. LeCroy. Littman. Pardue is here. Queen is here. Rochester. She stopped by the office a while ago. She's good. Roebuck. Satterfield. Hello, Satterfield. Satterfield not here. Dang old ads. Shaw. And how about my Smiths? Are they here? Both Smiths? Okay, neither Smith? Okay, the Smiths are losers. I'm just kidding. Vernon, Whitfield, loser. Williford, where's Mr. Williford? Not here today. And Wright. Okay, so I'm going to go over the ones that are not here. Satterfield, Smith, Whitfield, and Williford. Okay. I wanted to make sure they wasn't here. They quit school. No, they ain't quit school. They're just kids. It's a joke. All right. 627. And the reason I know that it's divisible by 3 is because I know that 3 times 7 is 20. 3 times 9 is 27. That's the only way I know, because I don't use divisibility rules that much. Okay, I only use the multiplication tables in my head. So, and those 627, 2, 3, 5, 7, 11, and sometimes 13. 3, well 3 will go into 6 2 times. That'll leave a 6. 6 minus 6 is 0. 3 will not go into 2, so that's a 0. And then 3 will go into 27, what? I got 209. What'd y'all get? 209. Okay. 9. Is there anything, let's see, 3 might go in there. No, 3 won't go in there because 3 times 6 is 18. That leaves 29. 29 is a prime number.
I think it's Brian.
Huh? I don't know, because what's the only number that'll go into 9? 3. Unless you do 13. I don't know, 13, let's see, 13 will go in there. 3 will go in there 1 time, and that'll leave, what, 79? No, 13 won't go into 79. I think we're done there. I ain't never done one that quick. Usually they don't give us numbers that are only 2. Usually 13 or 11 will go into it. Let's see what happens. 3 times 209. Yeah, I didn't think that was right. Yep, 11. So multiply 11 into it. 11 will go into, 11 will go into 20 one time. That'll leave 99. And how many times will 11 go into 99? We didn't try 11. We should have tried 11. I'm a loser. 11 will go into 20 one time. That'll leave 9. 99 will be 19. So your answer is 3 times 11 times 19. That one is pretty difficult because you have to depend on these two right here. Do not forget about these two. I just jumped up to 13. I should have tried 11. Let's try nerd. Now what happened, huh? You don't have to ask. Just go. Just leave. We'll make fun of you after you leave. All right. Now, what happens if you do one wrong in homework? You quit school, right?
Yep.
No, you hit similar exercise right here. And what does that do? Unless you take it over, and then it'll turn that X into a smiley face. So let's do a 483 and let's redo it. 483, because we sucked on that last one. So 483.
We had a calculator.
Oh yeah. If we had a calculator, we could not make change and look like a fool in front of everybody. 2, 3, 5, 7, 11, and sometimes 13. I'd rather try to do it by hand. I'm going to let y'all do it. Make sure some people aren't stand over. I try 3.
Oh, well, that's what I was going to go with anyway, so it's just a gut feel.
Yeah, 3 on the end, Well, 11 will go into 16 one time. That'll leave 5. 51. 11 won't go into 51. Might try 13 though. I don't know. Or 3. 3 will go into 16 5 times, right? That'll leave 11. So you just got to try all of them. Well, I wouldn't try 2 because 161. 7 will go into 16 twice. That'll leave 21. 7 will go into 21. It's a miracle. 7 will go into 16 twice. That'll leave 14. That'll leave 2. And then 21, dang old 3. Dang old calculator. Dang old man. So 7 will go in there how many times? 2. 2 times 7 is 14. What's 14 away from 16? 2. So they'll leave 21. 3 will go into 21 how many times? 7. And then 7. I'll check my math. I got 3 squared. Okay, 23. I was thinking 21 in my head. $23. There ain't nothing to go in there. So that's it. 7 will go in there. 2 times, yeah. So 3 times 7 times 23. 3 times 7 times 23. How do I know 23 is a... Because there ain't nothing will go in 23. So now you take your handy dandy cursor, type it in, and watch your X go away. go up here and type in 3 times 7 times 23, and watch your little X on 24 right here. Turns to a what? And what should everybody turn in on homework at the end of the semester? What? I said, what should everybody turn in on homework at the end of the semester? 100, will they? 27s, 32s, 56s. It's called, what's the word? Lazy. Lazy. All right, now what is this guy? Okay. What is the greatest common divisor and the least common multiple? Well, this is getting you ready to find the common denominators. What it's fixing to do. I don't really care about this guy, but I'll tell you what it means. The greatest common divisor is the number, the biggest number will go into whatever the given numbers. So let's look at these two numbers, 15 and 21. What is the biggest number that will go into 15 and 21? Well, whatever that number is, we'll find out in a minute. Whatever that number is your greatest common divisor. The biggest number that will divide into 15 and 21, which is 3. Because 3 times 7 is 21 and 3 times 5 is 15. But there's no other number. What about 6? No, 6 won't go into either. Okay, what about 7? 7 will go in 21, yeah, but it won't go in 15. Okay, so the biggest number that both of them will go into, the biggest number that will go into both 15 and 21 is this guy. Now, I don't care about this one that much, because this one is nice, but it's not what we're looking for. What we're looking for is the other one. And that is going to lead us into 5.2, which is the common denominator. And that is your least common multiple. And the least common multiple is the smallest number that the given numbers will what? Will go into. The least common multiple is the biggest number, the smallest number that both 15 and 21 will go into. Now that's going to be a bigger number. It's going to be way bigger than 21 because, now some people try to multiply together and that don't work because that will give you a BA number, and that BA number will cause you a problem when you're trying to convert the numerator and you're using this BA number and it's making math much more difficult. So don't do that. So how do you find it? Well, this is how you do it. First of all, you take your two numbers and you put them side by side and you draw your box. Just like before. 2, 3, 5, 7, 11, and sometimes 13. And now you start dividing. Well, you know that both of them are divisible by what? 3. So 3, and that'll be a 5 and a 7. And then I'm going to take a red marker and I'm going to put a red line under this. And I'm going to put R-M-E. Now somebody tell me, look at 5 and 7, and somebody tell me what is interesting about 5 and 7?
Right.
They're prime. So is there any other number that will go into 5 and 7? All right, and that's what I call the real math stops. In other words, the math that you grew up on that says, 2 will go into 4 2 times, 2 will go into 6 3 times. That math is stopped. We're going to use another type of math, and our goal is to get ones on the bottom. But we can't do that with divide 7 in both and divide 5 in both. Can't do that. Because if we said, okay, we'll get a 1 right here. Well, 5 will go into 5 one time, 5 will go into 7 7/5. You get 7/5 and it doesn't work. Okay? So we're not going to use real math that we use. We're going to use kind of a magic math. We're going to do it in blue. What's our goal? To get what on the bottom? 1. So I'm going to put a 5 here. And 5 will go into 5 one time. Hey, there's one of our ones. Will it go into 7? No. So you just bring it down. That little arrow means just bring it down. And what will go into 7? Make a 1. 7. We'll divide it by 7. And that'll give you a 1 here and a 1 here. And you're done. There's your 1. Now, what do we have? Well, in the black, we have our least common multiple. So the black, greatest common divisor is 3. And what's our least common multiple? Well, multiply all 3 of these together. Well, that's 35. 35 times 3 is what? 105? I'm sorry, somebody needs to calculate and do it faster. What's 35 times 3? Yeah. 105.
Hey, don't take my heat.
105.
105.
So, the smallest number that 15 and 21 will go into is what? 105. And later on, that's going to be called your common what? Denominator. And you're going to learn how to do that. So that's how you do it. Now this is where it really goes crazy if you try to use the trees. If you try to use the trees, it's confusing. Alright, let's try nerd. I'm going to leave this on the board for you. But go ahead and do 21 and 18. I'd put it in order 18 and 21 if I was you. Mr. Williford sent their doctor. Check. 18, 21, 2, 3, 5, 7, 11, and sometimes 13. What number will go into both of these right off the bat? 3. So you put a 3 here, and that'll leave you with a 6 and a 7, and the real math what? Real math stops. Why? Well, Hubert, 6 is composite. Yeah, but 7 ain't. Or is not. So give me a number that will both go into 6 and 7. I mean, 2, Nope, 2 won't go in 7. About 7. 7 won't go in 6. So you're done. You're going to have to stop. So we're going to put it 2. Good. So 2. We'll go 3 times, and this will come down. 3. This is 1. So we got 1 and 1. So we're good. And 7 comes down. And then what? 7, 1, 1. So here, I don't care about the first one, but the second one I do. I mean, you need to write the first one down. There's the first one, 3. I don't care about that. Okay? Now this is real easy. You don't have to spaz out, because you see this 7 times 2, that's 14. 14 times 9, you can do that in your head, 126. Or you can take 3 times 7 is what? 21, and there's 6. 6 times 20 is 120, plus 6 is 126. So there's 2 or 3 ways you could do this in your head. 126 is the answer right here. It would be. Unless I did my multiplication incorrectly. Did I?
I didn't put the 2 with the 6.
Should be 126 here and 3 there. So let's check it. Three. Good job. And 126. And we feel good about ourselves. So we don't have to put too much makeup on and look like an Oompa Loompa, right? You ever seen one of those guys? You ain't never seen an Oompa Loompa? Oh, I've seen them.
There's actually a girl at
school. There was one here a couple of semesters ago. Buddy, she looked like an Oompa Loompa. I'll show you. If y'all don't know what an Oompa Loompa looks like, you're sheltered, but I'll go ahead and show you. I'm sorry. I don't know what's wrong with me. And Hubert, I don't understand. Why are you talking about the Oompa Loompas? I'm not talking about the Oompa Loompas. I'm talking about these chicks. Talking about those chicks. Now, y'all seen these people, haven't you? They're like orange. Dang old taking shots. Dang old going to candy big.
Oh my God, did you see that butt?
Yeah. Anyway.
That's terrible.
Guys, you ever see somebody like this? Run. Run, 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 because they are crazy. Well, you can find them all over there. They're all over there. But anyway, there's a congressman that's Oompa Loompa. He's orange. There's some orange people. They're orange. Organized resistance against new attacks on gamma ray exposure. Meaning Tannabed. All right. So let's try this one. Now 195 and 351. Now after this one, I'm going to show you why this is so important. I have to quit on this one. You know why? Too big in numbers. Have to think too much. Yep. I quit. And look at the time. These numbers are too big. Dang old 3 will go into both of them. How do you know that? Well, you either use your divisibility rules, or you say 3 will go in there 15, 3 will go in there, let's see, that'd be 6, that'll leave 15, 3 will go in 15. 3 will go in there one time, 3 will go in there one time, we leave 21. So I just take my word for it, start with 3. I got those two numbers, y'all check them. We're going to 19, how many times? 6 times 3 is 18, that'll leave 1. 1 and 5 is 15, 3 will go into 15, 5 times. 3 will go in there 1 time, 3 will go in there 2 times. Oops, that's a mistake, hold on. Y'all won't let me finish. 3 will go in there 1 time, and that'll leave 21, 117. How about that? Is that better? All right, now, this one, we could easily say 5 goes into this one, but we can't say 5 will go into this one. The only thing I think about going into this one is maybe 3 or 11. I don't know if 11 will go into it. No, 11 will go into it. 3 will go in here 3 times, so leave 27. So yeah, 3 will go into that one, but will 3 go into this one? No. So the real math is what? The real math is over. It's done. And 3 is your greatest common divisor. So we know that 3 will go into this number, so divide 3 into it. 65 comes down. 3 will go in there 3 times. And that'll leave what? 3 times 3 is 9. That'll leave 27, which is 9. 3, we'll bring that down to 65. 3 will go in there 13. And then 13, the 1, and this 65 comes down. Well, 65, we know that 5 will go into 65 how many times? 5 will go into 65, 13, and then 13, there's that. So we got our 1, so it would be 5 times 13 times this, which would be 9, which would be 3 to the 3rd power, times 5 times 13 squared. So get your calculators out, and that'd be 27 times 5 times 169, which is going to be a BA number. Well, let's see. First one is 3. It's not? Well, we must have done something wrong. Y'all did something wrong. I didn't have anything to do with it. I did what y'all told me to do.
You're the one that suggested that 3 to begin with.
39. So that means 3 times 13. 13 will go in these two. Check 13.
Why do you always think about the 13 or 11?
Because you never use them. Will 13 go in there? Yep. So let's start over. Okay, let's go right here. So 13 Let's go with black. Yep, 13 will go in there, what, 5 times? Dang old 13. Dang old go in there 5 times. And 13 will go in, what's the only number? I'd say 9. 9 times 3 is 27. Yeah, 9. Yeah, because 9 is the only number that will give you a 7. Now the real math stops, and we get a 5. That'll give you a 1, and a 9, and a 3 squared. It'll give us a 1 and a 1. So 3 to the 3rd power times 5 times 13. And somebody multiply that out for us. Say again. That good? Well, since we got that one wrong, let's do it again. Make you feel good about yourself. 105 and 189. Don't lead me astray this time. Shelly, you're supposed to keep me on track. You're supposed to help me out.
I do it different,
I knew that was coming.
so I'm totally confused with how you're doing it.
Then don't do it. Don't do it the way I told you to. If you get the answer, if it ain't broke, don't fix it. I'm talking about the people that don't get the right answer. Alright. So 105. And 189. Well, I know that 105, I know that's divisible by 5, but the 189 is not divisible by 5, but they're both divisible by 3 probably, because of the 9 and the 5. So I'm going to divide by 3. 3 will go in here 3 times. That'll leave a 15, which would be 5. 3 will go in here 6 times. And 3 will go in here what? Now in this case, we know that by our multiplication tables, what will go into 35 and 63? 7. So you throw a 7 in there. And that'll leave you with a what? A 5 and a what? Now what? Real math stops. Good. Why does the real math stop here? Because nothing will go into 5 or 9 except for 1. So 5 give you a 1 and a 9. 3 give you a 1 and a 3. And 3 give you a 1 and a 1. So our least common multiple is 3 to the what? 3rd times 7, or I'm sorry, times 5 times 7. And whatever that comes out to be, what did you say? 945. Now, before I'm gonna go ahead and type this answer in so we can get a attaboy, little smiley face. 21 and 985. 945. And our little X turns into a check mark. All right, now let me show you where this can be used. Now this is just for an example. You do not have to write this down, because some of y'all are going to write it down and freak out because you can't do it, and that's not the whole point of me showing you this. Is to show you where this can be used. What's the two numbers that we just got? 105 and 189. So let's say we have 2 over 105 plus 3 over 189. Those are two what? Fractions. And they're not pretty fractions either, are they? So the common denominator that you just got was what? No, the common denominator, it was 945.
That's the least common number.
Huh? Yeah. That's the guy I want. I want the guy, the big number. I want the big number. What?
You
Look, what did I tell you I cared about back here? What did I tell you I cared about? Did I care about the little number or the big number? I care about this number. What was that number right there? That's the wrong one. That's the wrong one. Is that it? Yes.
Sure.
I said I would care about what? That's the number I care about. I don't care about this number. What's this number? 945? All right. Now, let's go back to this. I'm going to show you a trick learned in the war. All right? It's objective. All right? All right, let's take this and copy this. And I'm going to go over and here. And I'm going to file and here. And paste. Where's my paste? In the wrong place. Now this is the good part. Now you don't have to write this down. I don't want you to write it down because you're going to get confused. I want you to just watch. Does everybody agree that this number right here is 945? Everybody agree with that? All right. How many times will 105 go into 945? Well, you can do it two ways. You can do it in your head, or you can go over here and say, where's 105? Well, 105 is 21 times 5, right? So take out the 21 and the 5, and what does that leave? 3 times 3 is 9. So 9 times. 9 times 2 is 9 times 2 is 18, right? How many times will 189 go into 945? Well, you got to find 189. Or you can just say, well, 9 will go into 45, what, 5 times? So probably 5 times. But you don't have to do that. But where is 189 right here? Well, right there times this. 3 times 7 is 21. 21 times 9. That comes out to be 189, right? How many times will 189 go into 945? What's the only number left? 5. 5 times 3 is, and now you just add the 15 and 18, which is what? 32? 30 what? Okay, 33. 33 over 945. And see, that's why if you know how to get this number, then all your math is right here. All you got to do is just use the numbers. Huh? Okay? That's where we're going. But you got to crawl before you can what? So you got to be able to find that 945 before we use it. Y'all get out of here. Have a good day. I'm glad y'all got to see me. Thanks, Shelley, for keeping me on task. Don't know what I'd do without you. Watch out for those Oompa Loompas now.
There's a watch those right there in relation to those.
Adios.
See you, Queen.
Now, why can't I find these tests on there?
What test?
The final. Like you said, you know how you got our blocks?
I hadn't posted the test yet.
I know, I just asked you last week and you said, yeah, they're open. You don't
Wait a
know.
minute. We must be talking about two different things. What is,
Okay,
talking
you've
about-
got your 5-1, 5-2, 5-3.
Yes. I
you
hadn't
got
posted.
11-1.
Yeah, I
Okay.
hadn't posted the test yet. I'll post them when we get close.
When we get close.
Yeah,
I
we're
can't
on
just
5-1
run
right
through
now.
it.
You should have tried to test out of here. Why didn't you try to test out of here?
Because I ain't that smart.
Well, we'll have to. When I
This
get
is
close.
all that I am required to take.
Listen at you. Okay, I understand.
Alright.
All right, we'll see you.
What did you ever say about your stomach? Remember last
Never
semester?
could find anything wrong with it.
Hey, the body you sent for that, really.
Mm-mm.